When we examine the history of user interface design, we can see a clear pattern. Each major shift makes technology more accessible by reducing the gap between human intent and computer understanding. Command lines gave way to graphical interfaces, which evolved into touchscreens, and now we are also trying to figure out voice interfaces. What's fascinating is that these transitions were never simply about technical capabilities. They were deeply intertwined with our cultural expectations, cognitive patterns, and social practices. The WIMP interface that dominated computing for decades wasn't just technically superior to command lines. It aligned with our intuitive understanding of physical space and categorization. Today, we are witnessing the early stages of another profound shift in how we interact with technology, driven by large language models. This transition isn't merely technical, it represents a fundamental rethinking of the relationship between humans and computers. You've probably noticed chatbots appearing in many of your favorite apps. Meta recently integrated AI assistants into WhatsApp and Instagram. Apple is also trying to integrate Assistant to iOS. These integrations represent the first attempts at bringing LLM capabilities into everyday interfaces. But they are just the beginning. To understand where we are heading, I've identified seven distinct levels of LLM integrations. These aren't just technical distinctions, they reflect different philosophical approaches to the human computer relationship, with profound implications for how we'll interact with technology in the future. Today, we are primarily at level 1 to 2, with some applications just beginning to reach level 3. The higher levels represent where we are heading, not we are now. Level 1, the isolated assistant. Level 1 integrations are what we are seeing today. A conversational interface that exists alongside but separate from the core application. Think of Meta's AI in WhatsApp or the chatbot that appears in the corner of a website. These assistants function essentially as knowledge bases with natural language interfaces. They can answer questions about the world and sometimes about the app itself, but they have minimal awareness of what you are actually doing in the application. Consider what happens when you ask Meta AI to suggest restaurants for a friend's birthday dinner. It provides generic recommendations based on web information, completely ignoring that it lives inside an app filled with so much relevant context. Your location data, your friends' preferences from past conversations, events you have attended together. This disconnect isn't accidental. It's a reflection of how these tools were conceptualized. They were designed as additions to existing interfaces rather than rethinking the interface itself. It's comparable to how early automobiles were literally designed as horseless carriages before evolving their own design language. Level 1 implementation also reflect an important organizational reality. Adding a chatbot to an existing app is far easier than deeply integrating AI capabilities throughout the experience. It requires minimal changes to existing product architecture and also the team structures. Despite these limitations, level 1 integrations are valuable stepping stones. They're helping users become comfortable with conversational interfaces and helping companies in learning how people actually interact with AI in everyday contexts. Level 2, the contextually aware guide. Level 2 represents a meaningful evolution. The AI understands the application structure and your current context within it. Rather than just providing information, it can guide you through the interface. When you ask a level 2 assistant, how do I change my delivery address? It doesn't just explain the steps, it can visually guide you through the interface, highlighting relevant buttons and menus. It's like having a knowledgeable friend looking over your shoulder, pointing out where to click. What makes this possible isn't just technical capability, it's a philosophical shift in how the AI understands its role. Rather than being a separate entity that converses with you, it becomes a guide within the digital environment. This model of assistance has some historical parallels. In the early days of computing, software often came with extensive printed manuals. As interfaces became more complex, we created interactive tutorials and contextual help systems. Level 2 assistants represent the next evolution of this guidance approach. However, level 2 integrations maintain a clear division between guidance and action. The assistant can show you where to click, but you still need to do the clicking. This brings us to level 3, the active agent. Level 3 marks a significant threshold we are just beginning to approach. The AI can now take actions within the application on your behalf. Instead of just pointing you toward features, it can activate them directly. Consider the difference between these interactions. User says, cancel my subscription. Level 2 AI will say, to cancel your subscription, go to settings, then account, then subscription, and click cancel. Whereas on level 3, the user will say, cancel my subscription, and level 3 AI will say, I can cancel your subscription for you. Your current billing period ends on May 15th. Would you like me to proceed with cancellation? So, you see the contrast between these two. This capability fundamentally changes our relationship with digital interfaces. We shift from tools that we directly manipulate to environments where we can delegate tasks through natural language requests. Notion's database creation features operate at this level. When you ask Notion AI to create a database, it generates the basic structure based on your description. However, the configuration options it represents are pre programmed, and the responsibility falls largely on you to refine and customize the setup. The AI takes the action of creating the database, but the remaining interface is still traditional rather than adaptive. However, this shift introduced new complexities around trust and agency. When we directly manipulate an interface, we maintain a sense of control over the outcome. When we delegate actions to an AI assistant, we must trust that it will correctly interpret our intentions and execute them appropriately. Well designed level 3 integrations balance convenience with control through mechanisms like confirmation steps, clear previews of actions before execution, and easily accessible undo capabilities. These aren't just interface elements, they are expressions of design philosophy that respects user agency. Some companies will experiment with completely replacing traditional interfaces with conversational ones. At this level, removing buttons and menus entirely in favor of natural language requests. While theoretically more natural, these approaches often fail because they violate a fundamental principle of cognitive psychology. Recognition is always easier than recall. Seeing available options arranged visually, which is recognition, is cognitively easier than having to remember and formulate what's possible, which is recall. When interfaces become purely conversational, the burden of remembering what's possible falls entirely on the user. This creates serious discoverability problems. How do users learn what they can ask for? This insight leads us to level 4, which represents the next frontier. Conversational context with adaptive UI. Level 4 integrations achieve a thoughtful balance. They use conversation as a primary interaction model, but dynamically generate specialized UI components when appropriate for the task at hand. This approach acknowledges that different tasks are best suited to different interaction modes. Natural language is excellent for expressing goals and preferences, but visual interfaces are often better for browsing options, making selections, or manipulating data. In the demo that I have created in Claude, you will see how this level of integration might work, where conversation triggers contextual UI elements that are truly responsive to the dialogue, not just pre programmed components. The philosophy behind level 4 is that interfaces should adapt to human communication patterns rather than forcing humans to adapt to interface conventions. It's similar to how skilled human assistants naturally switch between conversation and visual aids depending on the task, showing you a map when giving directions or a catalog when helping you select products. Achieving level 4 requires more than technical advancement. It demands fundamental organizational restructuring. Product teams need to think beyond static screens to conversational flows with dynamic visual elements. This represents a significant shift in how we approach product design, requiring new collaboration models between conversation designers, and UI designers. While some experiments are beginning to approach this level, true level 4 integrations remain largely in our future. Today's implementations like Kayak's chatbot that pulls in flight widgets are taking steps in this direction. But these widgets aren't truly dynamic. If you ask to change currency in conversation, the widget itself typically doesn't update. This also brings us to the trust dimension. Before continuing to the higher levels of integration, we need to address a crucial dimension that crosses all levels: trust. Our willingness to delegate tasks to AI varies dramatically depending on context and stakes. This isn't unique to AI. It reflects how we approach delegation in all aspects of life. We might readily accept movie recommendations from an algorithm, but be hesitant to let it manage our retirement investments. We can think of this as domain specific trust thresholds, the level of confidence we need before delegating a particular type of task. Entertainment and information recommendations have relatively low thresholds. Financial decisions, healthcare, and personal security have much higher thresholds. These thresholds explain why we are seeing faster adoption of advanced LLM integration in some domains than others. Netflix can experiment with AI driven interfaces because a bad movie suggestion has minimal consequences. Banking apps proceed more cautiously because errors could have significant financial implications. Level 5: the adaptive interface. Level 5 takes a fundamentally different approach. Rather than containing the LLM within a conversational interface, it infuses intelligence throughout the entire traditional UI. The interface itself becomes dynamic, adapting not just based on predefined rules, but on a deep understanding of your intent, context, and patterns of use. Imagine a productivity app that gradually reorganizes its interface based on how you actually use it, bringing frequently used tools forward, combining commonly used features, or suggesting workflows based on your current project context. Or a form that automatically populates fields based on your likely intent, derived from understanding your current task. These adaptations aren't triggered by explicit requests, they happen naturally as you use the application more and more. The intelligent becomes ambient rather than contained in a separate conversation. This approach has philosophical roots in the concept of calm technology, proposed by Mark Weiser and John Seeley Brown at Xerox in the 1990s. They envision technology that informs but doesn't demand our focus or attention. Level 5 integrations bridge the gap between conversational and traditional interfaces. They maintain the familiar paradigm of visual interface elements while making those elements more responsive to context and intent. This approach is particularly valuable for complex professional applications where users have established workflows and mental models. This approach is particularly valuable for complex professional applications where users have established workflows and mental models. Rather than replacing these entirely with conversation, Level 5 integration enhances them with contextual intelligence. Level 6: cross application orchestration. Level 6 moves beyond individual applications to the operating system level, allowing for seamless coordination across multiple services and tools. At this levels, the boundaries between applications begin to dissolve. The organizing principle becomes a task you are trying to accomplish rather than the application you are using to accomplish it. Consider a request like prepare for tomorrow's presentation meeting. A level 6 integration might check your calendar for meeting details, retrieve the presentation and related documents from your storage, summarize relevant emails about the topic, prepare talking points based on the presentation context, suggest updates based on recent information, set up a pre meeting reminder. This happens as a single coherent flow rather than requiring you to manually switch between calendar, file, email, and other apps. Technical developments like the Model Context Protocol (MCP) are making this level of integration increasingly possible. MCP provides a standardized way for application to expose their capabilities to LLMs, similar to how USB standardized device connections. This standardization is crucial because it allows for integration without requiring each application developer to build custom connections to every other application. It creates an ecosystem where applications can interoperate through a common language. However, achieving level 6 requires first mastering the earlier levels within individual applications. Until we have robust level 3-4 implementations widely available, truly seamless cross application orchestration remains aspirational. The philosophical shift at level 6 is from application centric to task centric computing. We stop thinking about which app to use and focus instead of what we are trying to accomplish. The privacy and security implications at this level are significant. For cross application orchestration to work effectively, the system needs access to data across different services. This requires thoughtful approaches to permission models, data minimization, and transparent control mechanism. Level 7, Ambient intelligence. Level 7 represents a vision where LLM powered interfaces extend beyond screens to become part of our physical environment, anticipating needs before we explicitly express them. At this level, the interface becomes proactive rather than reactive, offering assistance based on an understanding of your context, routines, and likely needs at any given moment. Imagine walking into a conference room and seeing relevant documents automatically appearing on displays, personalized to your role in the meeting. Or while you are cooking dinner, you receive gentle guidance about the next steps in a recipe, which are timed precisely to your progress so you don't have to touch the screen with messy hands. The concept of ambient intelligence has roots in Mark Weiser's vision of ubiquitous computing. From the early 1990s, he imagined computing that will weave itself into the fabric of everyday life until it is indistinguishable from it. What's changed since Weiser's time is that LLMs now provide a sophisticated contextual understanding that can power these ambient interactions in a natural way. For ambient intelligence to succeed, restraint is as important as capability. The system must understand not just when to engage, but when to remain silent. It should enhance your environment without intruding upon it or creating new distractions. This balance requires a deep understanding of human attention, social context, and personal preferences. It's not just about what the system can do, but about what it should do in each moment. One of the fascinating paradoxes of technological evolution is that as systems become more advanced, they often appear simpler from the user's perspective. Consider how we interact with electricity. When we flip a light switch, we don't think about the complex power generation and distribution system. The infrastructure has become invisible, allowing us to focus on the light rather than the electricity. As LLM integrations evolve through these 7 levels, the interface in the traditional sense gradually recedes. We move from manipulating clearly defined controls toward expressing intentions in natural ways. The technology adapts to us rather than requiring us to adapt to it. The progression isn't linear across all domains. Different applications will advance through these levels at different rates depending on their specific context, user needs, and trust requirements. Let's revisit the metas approach. These level 1 implementations represent first steps rather than final destinations. As these platforms evolve, at level 2, the assistant understanding your conversation and social connections, helping you navigate to relevant features or find information within your existing messages. At level 3, the assistant taking actions for you, scheduling events when friends discuss plans, or ordering food when a group decides on dinner. At level 4, integrating contextual widgets within conversations, showing restaurant options with reservations capabilities when planning dinner, or presenting a poll interface when friends are deciding on a movie. At higher levels, the distinction between chatbot and app would begin to blur. The messaging interface itself would become more responsive to context, intelligently organizing conversations, suggesting responses based on relationship dynamics, and seamlessly connecting with other services. What makes messaging platforms particularly interesting is that they are fundamentally social spaces. The trust dynamics aren't just between user and AI, but between users mediated by AI. This creates unique challenges and opportunities for integration. So, what's the deeper meaning behind all this? Throughout human history, our tools have shaped our culture in profound ways. From the folk changing dining etiquette to the automobile transforming urban planning, technologies are never neutral. They embed. and reinforce particular values and ways of being. LLM powered interfaces represent more than just technical advancement. They reflect an evolving philosophy about the relationship between humans and technology. For decades, we primarily designed technology that requires human to adapt. We learned special commands, navigate artificial organizational structures, and translate our intentions into machine friendly formats. The progression through these 7 levels represents a fundamental shift in that relationship, creating technology that increasingly adapts to human needs, contexts, and natural forms of expression. This shift has profound implications for accessibility. By reducing the cognitive prerequisites for using digital systems, these new interfaces could make technology accessible to people with different abilities, technical backgrounds, and context of use. As we move forward, the key challenge will be balancing technological capability with human values, creating systems that are helpful without being intrusive and that understand us without overstepping boundaries. The most successful implementation won't be those that simply advance to the highest technical level. They'll be the ones that thoughtfully integrate these capabilities in ways that genuinely enhance human experience while respecting our autonomy and diversity of preferences. The future of interface design isn't just about technically possible, it's about what's humanly desirable. As these levels unfold, they reveal not just new ways of interacting with technology, but new understanding of what technology means in our lives. If you found this exploration valuable, then stay tuned. My channel examines the deeper pattern in design and technology and how they shape our experience. And let me know, what level of LLM integration do you think will be most transformative? I want to hear your thoughts. And thanks for joining me in exploring how technology is evolving to better serve human needs. Until next time.